What is up, guys? It's RJ Makes Animations here, and this is how I made my own tic-tac-toe game in Python's turtle function. If you want to see how I made this game, the source code will be in the description. Alright, so let's get started. In this video, I actually assume you have the TK interface package installed, but it's not that hard. If you haven't, just quickly search up how to do that and install it, and then you can get started to come back to this video. So we start off with our imports from turtle import asterisk. That just makes it a whole lot easier for us, for our turtle to work. So instead of writing full on, for example, this is hide turtle, I just write HT, because that's how the computer can read it now. And we import time because we do have some time delays at the end here. There we go. We timed out sleep 0.5 so that it doesn't keep changing. But this is a long time. You won't. It's not understandable currently. So let's get started. I set my background color to gold. I hide the turtle. I change my color of the background color turned gold, and I change the color to Dodger blue, which you will see is the actual board itself, and the width is 10 because that's about the widest you can get it to have a thickness on the lines instead of being paper thin. I'm gonna make sure to have the speed as fastest because, well, you know, we don't have a fast program, we want it to load fast. And then we turn the pen up because we don't want to draw anything currently. Then we make a turtle called double T. Double T, it doesn't draw anything, and you hide the turtle. When it goes to a position around a lower part of the screen and writes loading assets. Well, now you might be asking, if you write down loading assets, won't it just stay there forever? Well, when we go further and all of these turtles are finished loading, we just have S1. Sorry, wait, where is it? I can't find it. Oh, it must be after all the S ones. Sorry, it's all the way down here. Double T dot clear basically takes all of it away, and then we write play, so the user knows that you have to play the game now. Then we build this code, basically just builds our board, this exact code, right? And then we write tic-tac-toe on like lines, and then we put some random emojis because, you know, I can do whatever I want. Then we make our first actual turtle. This is X1, which, I mean, this is the first turtle. It doesn't really do anything yet because it just exists. You hide it, right? And so it's not visible. And that's why there's a bunch of arrows in the middle while we are running the code. We make sure all these base settings are put, and then we set the position to exactly where we want it. Oh, whoops. Exactly where we want it, right? So then we had the color as red because X is going to be red and O is going to be blue, and we do that exact same thing 9 times. X1, X2, X3, X4, X5, X6, X7, X8, X9. So that's 9 turtles. I'm sure there was a much faster way to make this game, but you know, I'm still a beginner, so I'm doing with what I have, with the knowledge I have. So then we do the exact same thing with O, and the only difference is the color is blue. Oh, sorry. By the way, each of these turtles have a different position on the board, right? So this one is 90 pixels, X90 and Y100, and this one's X90 y minus 100, because each time it goes down by 100. That's how I thought the best. Sorry, down by 200. That's the way I thought it was best. So then 90, 100, 90 minus 100, 90 minus 300, and then we're going like to the left. Sorry, to the left? Yeah, I think so. To the left. Now we 100 minus 110, 100 minus 110, minus 100 minus 110, 300, and then we go one more minus 310, 100 minus 310, minus 100 minus 310, minus 300, and the exact same positions for all the O's. That's about it for the first few turtles. Then we have right x1, which is basically also going to be, oh, whoops, how did this get here? One sec. There we go. This is, one sec, sorry. Right x1 is our first program. Sorry, no, function. It's our first function. And all it does is write x1, right? It makes the x appear on the screen. And then what it does, it makes the original actual like turtle go to like some random coordinate, and then it shows it. And then also hides the, what do you call it? The square, you see. I didn't show this yet, but I created a turtle. Why are these here? I still don't understand. Sorry, one sec. Oh, that was actually there for a reason. I'm sorry. Silly me. There we go. Alright. So, S1 is a turtle. Alright, so now we have a turtle called S1. Now we make this turtle for the sole purpose that when someone puts an X there, we remove it from a there's a list that I made called turts. And when I remove it from turts, it takes, so to understand that we have to go all the way down here. So we start here. While the length of turts is 9, on the click of any of these squares, we go to the next one. Correct? So whenever you click on any of these squares, the length of turts decreases because whichever one you took out, right? So it keeps going like that until it's our first possible time where you can get a, like, 3 in a row, correct? And then we keep going, and keep writing the code. So back to where we were on the S1. Right, make sure it's not a square, right? It's a little bit different from a square. Stretch width. It's like a rectangle type shape. So it goes to the exact position over top the other one. The X, whichever X it's on. And yeah. Then we have the second right. Then we have right X2, which is the code to write the second X, and then we have define S2 down here. We have that same thing go multiple times. Just remember that each of the S squares, which is S, each of them has a different coordinate. So we have S5, S6 all the way down to S9 because there's 9 squares. And then we finally go to double t.clear because the assets are done loading finally, and then we write play on the exact spot where the other one was, right? Now we do the exact same thing except without the S's because the S's are done loading. So we define right O1, right O2, right O3, right O4, right O5, okay, right all the way until O9. And those are basically the exact same thing as the right X, well, X at right X state, right Right X functions, except for the fact that it's calling the O variable instead of the X variable, and most of it actually the same. And then we come to the main part, which I found was pretty smart of me, that I created a list called turts, short form for turtle. I don't know, I just name them whatever I want. I can do what I want, right? Then, while the length of turts is 9, which it is at the beginning, on the click of each of them, you run the right X function. And then since the next turn, X doesn't go, right? So then you do the right O function. The next turn, you do the right X function, then O, then X. Now, this is the first place where we have one of these. This is the if statement, right? So, if any of these, if x1 and x2 and x3, right, are visible, or x4, x5, x6, x4, x5, x6, or x7, x8, x9, or x4, x1, x7, and all of these, correct? These are all, what do you call it? These are all different cases of 3 in a row. So if any one of these are true, then, if any one of these are true, you clear the screen, hide the turtle, and run this code, which basically writes X wins in the center, and forever it just keeps looping colors. That's it. That's literally it. And the reason I said is visible is because, remember back in the right X and right O functions, I wrote go to 1000 1000 and then show turtle. Now the reason I did that is so that the only way for these turtles to be shown was if they were clicked on, right? So if they're clicked on, they're shown. So if all of these turtles are visible, then that means they were, all 3 of them were clicked on, which makes this code run. Then you click on it, this works, it runs, correct? Then we go to the for, while the length of turts is 4. If O1, sorry, a little bit of a cold, but if O1 and O2 and O3 and the same thing, which is up here, are visible, then we run the same code except it writes O wins. And then we do the same thing for 3 except X wins, and so on and so forth. 2, 1. Now for 1 it changes just a little bit slightly. All this code is the same, but now we have an else statement. Why do we have an else statement? Because if no one won, then the only case is a tie. So it runs the exact same code as this, except it writes tie. Well, that is the end to our code. 671 lines of a completely beginner game. If you want to start Python, that's like a really good game for you. Yeah, hope you enjoyed the video, and yeah, bye. See you in the next one.